Bismillahirrahmanirrahim. Dear students, we are talking about the lecture number 42 and lecture number 16 and grade 12. Benzene and its substituted benzene means derivatives. When we are going to put another groups with the benzene ring. In the previous lecture, I told you that the position of benzene, all the positions are equivalent. There is a carbon, carbon, carbon and carbon, all are equivalent. If I put chlorine here, this is also called chlorobenzene. And if I am going to put here, this is also called a chlorobenzene. So all these positions are equivalent. So this is the difference between the alkenes and benzene due to delocalized structure, delocalization. So I told you in the previous lecture that if you put the CH3, this is called toluene. If OH, we call phenol or carbolic acid. If you are going to put NH2, this is called aniline. Last time I told you this. If you put COOH, this is called benzoic acid. If you are going to put here alkene, this is called styrene. This is called styrene or ethylene benzene. If you put NO2, we call nitrobenzene, bromobenzene. If you are going to put here CHO group, benzaldehyde. Benzaldehyde. And if you are going to this is an isopropyl benzene. Isopropyl benzene, or we call cumene. So these are all mono substituted benzene here. So when you are going to put another, we call bisubstituted. Bisubstituted benzene, then there is a rule you have to follow. Like this. So if there is an alkyl group and we put the alkyl group also here, then you have to make a one reference. If you make this reference, then you have to move from group to group here. Or if you make this reference, then you have to move group to group here. This is called a reference. This is a reference. After this reference, this position is called this position. This position is called ortho. This position is called meta. And this position is called para. Same. There is a group, that's why we are going to move here. Otherwise, this is also ortho, meta, and para. But we have to move this side because there is a group here. So, dear students, the name of this compound is called, if the two same alkyl groups are attached with a benzene, we call xylene. We call xylene. So the position of second group is ortho, so we call orthoxylene. Or only O-xylene. Orthoxylene or O-xylene we call this one. And if you are going to put this At this position, so this is called metaxylene. This is a metaxylene because this CH3 group is attached to the meta position. And if you are going to put the CH3 group, alkyl group, methyl group at this position, then we call p-xylene, paraxylene. So one is called orthoxylene, second is called metaxylene, and third one is called paraxylene. Ortho, yeah, or we can say ortho. This is the ortho position, ortho dimethyl benzene, meta dimethyl benzene, para dimethyl benzene. There are because two methyl group are attached. So you can write also this one. Para dimethyl benzene because the CH3 group is at para position. If the CH3 group is at this position, then we have to call ortho dimethyl benzene. And if the CH3 group is this position, then you have to call meta dimethyl benzene, or we call metaxylene or orthoxylene or paraxylene respectively. So if these two groups are present here, same, so we called here ortho dimethyl benzene, meta dimethyl benzene or para dimethyl benzene, or we call xylene here. So these are the same groups, ortho position, meta position and para position. If there are different groups attached here, suppose in your book it is written here is the same CH3 and this ortho group is chlorine. So when you are going to give the name, so mostly we use alphabetically according to A, B, C. Means this is the position ortho and there is a chlorine, so we call orthochloro. Orthochloro. Then CH3 is attached to the benzene, we call toluene. Orthochlorotoluene. So in your book this is same written, orthochlorotoluene. Orthochlorotoluene. Or there are another also, according to IUPAC system, you have to give the names. So this reference point you have to take a 1, 2nd, 3rd, 4th, 5 and 6. So this chlorine is attached to the group number 2 here. So 2 chlorotoluene. 2 chlorotoluene. So this is the IUPAC system. And if there is a OH group, if you are going to put here OH group, and here is a, suppose, bromine. So this is a reference point, more reactive site, and this is a ortho position, this is a meta position, and this is a para position. Or starting from here, this is a 1 position, this is a 2 position, this is a 3 position, this is a 4 position, 5 position, and 6 position. So alphabetically, this is the para position, so we write P bromophenol. Para bromophenol, or we call at position number 4 bromophenol. Para bromophenol or 4 bromophenol we call this one. And if there is this IUPAC system, so alphabetically you have to give the names. Now if there are more than 2 substituents are there, polysubstituted benzene. According to the rule, polysubstituted benzene are named by the numbering the substituent of the ring so as to give the substituents lowest possible numbers. Lowest possible numbers, just like if you have like this one. If you have benzene here and there is an amine group, and if you are going to substitute more than 1 here, so if chlorine is here and if the chlorine is here, 2, there are 2 substituents, so you don't move here, nearest. So this will be a 1, this will be a 2, this will be a 3, this will be a 4, this will be a 5, this will be a 6. So starting from the here, 1, 2, 3, 4, 5 and 6. So nearest position is a 2 here. This is the array if you start from here. So substitute, this is the main amine group is more reactive, so we start from here. So the name of this compound will be a 2 and there is a 4. So 2, 4 dichloro, and this NH2 is attached benzene we call aniline. Aniline. 2,4 dichloro aniline. So this is the polysubstituted group. If like this one, like this one. Now if this compound, so this is the number 1 which is showing reactivity. This is the alkyl group. Starting from here 1, 2, 3, 4, 5, 6. From this side 1, 2, 3, 4, 5, 6. So same. This is number 1, number 2, number 3, number 4, number 5, and number 6. So now 2, 4, 6 try nitrotoluene. Trinitrotoluene, and we generally call TNT. We call TNT, and it is a highly explosive. TNT is highly explosive like this one. And if like this one, if there is a OH attached, nitro group, same 2, 4, 6 try nitrophenol. 2, 4, 6 try nitrophenol. This is an explosive we call picric acid. Again, it is explosive. 2, 4, 6 trinitrophenol. 2, 4, 6 trinitrophenol. Isoprotoluene, TNT or picric acid. Okay. So these are the polysubstituted benzene when more than two groups are attached with the benzene here. There are many other, if I am going to mention here, in your book. And I advise you, please, you have to put this big, not small. It will be long. This shows resonance. This shows the resonance, and it should be big one. So dear students, if you put CH3 here according to your book, if you put CH3 here and CH3 here and CH3 here, like this one. So the IUPAC name, you don't start from here. This is the empty. Must start from this side, this side, this side, this side, then nearest. So if I start from this side here, from here to 1, 2, 3, 4, 5, 6. Means 1, 2, 4, 6 means. And this will come here 1, 2, 3, 4, 5, 6, same. So you can start from any point. 1 or here 1, 2, 3, 4, 5, 6, same. So 1, 2, 3, 4, 5, 6 like this one. Now the name will be 1, 2, 4, 5, tetra, methyl, benzene. 1, 2, 4, 5, tetra, methyl, benzene. Or we call it diurene. Common name. It is also called diurene. So if you see other also, there are many. In your book, I am going to write from the activity. From your book, it's like this one. This is a chlorine. This is a chlorine. And this is also chlorine. This is the activity if you see. So here, same group, all the three identical groups. So if you start from here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. So you have to select least one. If you start from 1, 2 position is empty one. Then 3 and 4. But if you start from here 1 and 2. 1, 2, 3, 4. Or 1, 2, 3, 4, 5. Again array. So you must start from here 1, 2, 3, 4 least. 1, 2, 3, 4, 5 more. 1, 2, 3, 4, 5, 6. So there is a gap. So you must start from this side. 1, 2, 3, 4, 5 like this one. This is the nearest. So the name of this compound is 1, 2, 4, chloro, 4-trichlorobenzene. Now if this is styrene, this is called a styrene, double covalent bond styrene, and if I am putting chlorine here, so then this is the main reference 1, 2, 3, 4, 5, 6 like this. Or this is a reference ortho, meta, para. This is a reference. Also you can go from here. This is a 1, 2, 3, 4 same. This is a reference ortho, meta, para. Or ortho, meta, para same position. So name of this compound will be 4-chlorostyrene. 4-chlorostyrene or p-para-chlorostyrene. 4-chlorostyrene or p-chlorostyrene. So these are given in your book and you have to solve them. Now dear students, after the nomenclature of the benzene aromatic hydrocarbons, there is also note of its physical properties. In the absence of polar substituents, other substituents if they are absent, arene, this is the arene, benzene is called arene, aromatic, typical of the hydrocarbon, low melting point, boiling point, non-polar, low solubility in the polar solvent and it is soluble in non-polar solvents. There are 6 carbon atoms, 6 hydrogen atoms, total there are 12. Molecular mass is 78 grams per mole. Benzene has a planar cyclic conjugated structure. Planar cyclic conjugated structure. Same plane. So conjugated means we done the conjugation system in the previous. So you have to start from here, then alternate position like this one. So alternate, the 3 bonds are present in the benzene and we put in the big cycle. If one draws benzene as alternating, yes, carbon double bond, then carbon single bond, then carbon double bond. So this is according to the scientist we called cation structure. We will discuss. So students, if you are going to draw any point, you can start. Suppose I am going to start from here. This is one double bond, this is the second double bond, and this is the third alternate. Or you can start from here. First double bond, second double bond, and this is the third double bond. So this sign is called resonance. This is a resonance means in between these 2 structures there is a structure of benzene. In between these two structures, there is a structure of benzene. Means you can write this one, this is also correct. You can write this one, this is correct. This is according to KQ. This is the KQ structure. So in both, for the both structures, we represent like this one. Like this. This structure represent both. This structure represent both. So this structure is from Robinson's. This structure is from the Robinson's. So this is the best representation. You can, this is also good one, this is also good one, you can write both, but this is the best one, but you have to put the big circle inside, because if you are putting like this one and if you are going to join, you will find a big circle. So this resonance should be big one. This shows representation of the three double bonds which are circulating inside. So this is a resonance which is given in your book also, or maybe it is wrong, but see either correct or wrong. So there are alternate three double bonds. They are going to combine in the resonance hybrid by the conjugated system by the representation of circle we call Robinson's structure. Note that all carbon single bonds, the distance single bond is 1.4 angstrom, carbon single bond 1.4 angstrom, and carbon double bond distance is going to be less for this one. So when the representation of structure benzene in the best, this Robinson structure I told you is the best one, but you can also write these are also good one for the representation of the carbon double bond and carbon single bond. So since the key of organic chemistry is being able to understand mechanism and the drawing of curved arrow to account the position of electron, so the KQ structures given a more precise description of the electron position can avoid destruction. Therefore, it is a good idea to use KQ representation. So KQ representation is the best one when you put like this alternate here. Dear students, there is a very important point here. How the benzene has three alternate double bonds. So you learn in the grade 11 hybridization between carbon and carbon atoms. When you done the methane CH4 or ethane CH3 single bond CH3 two carbons alkanes, so there was a sp3 hybridization. In single bond sigma bonds or no pi bond, there was a hybridization sp3. The topic we are doing here is molecular orbital treatment of benzene. molecular orbital treatment of benzene. Molecular orbital treatment of benzene, or we call modern structure of benzene. Very important this topic. Modern structure of benzene. As I told you that these bonds are called delocalized alternate bonds. We call them delocalized bonds. So due to the delocalization, the benzene structure, benzene molecule is more stable. The structure of benzene is more stable. Due to its stability, reactivity will be decreased. So that's why the order of reactivity, already in the previous lectures I told you, alkenes are the most reactive. Alkenes, then alkynes, then benzene, and then alkane. First alkene, then alkynes, then benzene, then alkane. So it means that these are the most stable and less reactive. Okay. And also one point I told you in the previous lecture, the reactions of benzene. Reactions of benzene, two types. One type is called substitution reaction. One type of chemical reaction is called substitution reaction, and other type is called addition, because it is highly unsaturated. Substitution, I told you, this is a substitution. If you are going to remove the hydrogen from here, hydrogen is removed from here and nitro group is added. So nitro is electrophile and hydrogen is electrophile. So this nitro group substitute to hydrogen. So this reaction is called substitution reaction. And if the benzene is going to be changed into cyclohexane, when you are going to add hydrogen by certain conditions, is a cyclohexane. So these double bonds are going to remove. Hydrogen is added. So this is saturated one. This reaction is called addition reaction. So dear students, already I told you the substitution reactions are frequently given by the benzene. Substitution reactions are frequent, easily, and addition reactions are reluctantly. The benzene feel reluctant while giving addition reaction due to the high stability and due to the resonance structure. So due to the stability and resonance structure, resonance Hayward delocalization, so benzene shows reluctant in addition reaction. So generally we have a two. So substitution reaction is more frequently will give by the benzene. It is less heat of formation. It has an equal carbon-carbon bonds. So dear students, if we use the spectroscopy, instrument, so spectroscopic studies are X-ray analysis of the benzene. So already I told you benzene give a planar, flat planar, hexagonal conjugated structure. Spectroscopic studies or X-ray analysis show that benzene has a planar cyclic conjugated structure. I wrote early, if you see back, all 6 hydrogen atoms are coplanar with the 6 carbon atoms, and if you see the angles are given here, so carbon, carbon, carbon single bond, carbon, carbon single bond angle is 120 degree, and this is the angle. Carbon, carbon and hydrogen angle is also 120 degree. So all these are same, means this is a carbon of benzene center. If we are talking about this one, this carbon, this carbon, this carbon, and there is a hydrogen here. Now I am writing same. This is a carbon, I write here this carbon, and there is sigma bond between the carbon and hydrogen, and there is a carbon here, and there is a carbon here. So these angles are all 120 degree. All 120 degree angles. Carbon carbon angle and carbon hydrogen angle is 120 degree angle. Okay, now we were talking about the hybridization. Students, if there is a double bond, means between the carbon and carbon there is a double bond here. So one bond is a sigma bond and other bond is a pi bond. One bond is a sigma bond, and you know that first ever bond is formed is called sigma bond, and next will be the pi bond. And sigma bond will be only one in between the two atoms. One bond should be sigma bond. More than one pi bonds may be formed. In the case of triple covalent bond, you will find one sigma and two pi bonds. But if there is double covalent bond, there is one sigma bond and one pi bond. So dear students, in the pi bond there is no hybridization. Pi bond is not formed by the hybridization process. Sigma bond is formed by the hybridization process, maybe sp3, maybe sp2, maybe sp hybridization. So that is why when you are going to form a pi bond which is formed by the unhybridized atomic orbital, so one 2p is gone. So that's why in the benzene there is a sp2 hybridization. There is a sp2 hybridization. So, how many sp2 hybridized atomic orbitals? There are 3. So, if this is a carbon here, center, this is the one sp2 hybridized, second sp2 hybridized, and this is the third sp2 hybridized. There are 3 sp2 hybridized atomic orbitals for each carbon. And you know in the benzene there are 6, 1, 2, 3, 4, 5, 6 carbon atoms. So meaning you have to utilize 18 sp2 hybridized atomic orbitals you have utilized for the formation of the ring, circle. And this shows that benzene has a circular orbit, circular. If you see the structure of the benzene, so thus each carbon is a state of sp2 hybridization. Already I told you, because carbon atom is attached to 3 atoms. This carbon attached to 3 atoms. This carbon attached this carbon, this same. This carbon attached this carbon. This carbon attached this carbon, this carbon attached hydrogen. So that's why this sp2 attached with the hydrogen here, like this one. Sigma bond with the hydrogen, and this carbon is going to attach another carbon like this one. This carbon is going to attach this carbon like this one. So this is the sigma bond between sp2 and s, like this. You will find the planar, regular planar structure you can see on the page number 147. So combination of 6 structures and overlap of 6 hydrogen atom of 1s1 of the hydrogen. So you have a framework cyclic of the benzene. 6 atomic p orbitals to form a pi bond. 6 atomic orbitals of the benzene carbon atom to form a pi bond, because I told you in each carbon 2pz. One is unhybridized. 2pz, one is unhybridized. There is no hybridization in the 2pz. So each carbon has one, so 6 carbon has 6 unhybridized atomic orbitals. So that's why the Strengths structure is like this one. Like this. All these are sigma bond sp2 hybridization. S sigma bond, sigma bond, sigma bond, sigma bond, all sigma bonds with the sp2 hybridized atomic orbitals. So when there is a 2pz, 6, each carbon has 6. This is a 1 2pz, second 2pz, third 2pz, fourth 2pz, and fifth 2pz, sixth. There are 6 2pz atomic orbitals. 6 2pz atomic orbitals. They are going to form pi bond, like this one. Overlapping here, and this is going to be overlap here, and here overlapping. You can see this one, and you can see this. They are overlapping here, and also there is overlapping, and there is going to be overlapping here. So this is going to be give the pi bonding in this case, or you can this one. All 2pz. You can form in this case also. See, there is another cyclic. There is another cyclic. So you are getting another cyclic here. And if you are going to form another one, like this one. So sandwich In between the original sigma bonds up and below, you are finding the this hexaball is in the down and one hexaball is on the up, and the original sigma bonds in the middle. So you will get a sandwich like this molecule. So according to this molecular orbital picture, each carbon bonded is a benzene consists one of the sigma bond and half a pi bond. Because of reason, the carbon-carbon bond length in the equal benzene shows substitution as well as addition. The reaction, this is the reason because I told you. And there are the delocalized pi electrons are here, and which spread over the carbon nucleus above and below according to this structure. And this delocalization of pi or p orbitals over entire ring produces sandwich-like structure of benzene. Sandwich in between the original sigma bond, and this is the upward and this is the downward. So in between there is, you can see in your book also. So sandwich-like structure of benzene and decrease the energy of molecule. So consequently the molecule becomes more stable and less reactive. This is the reason. The benzene molecule is a more stable, less reactive. That's why alkenes are the more reactive, double bond, alkynes triple bond, then double bond, benzene, then alkane. So students, you have to see this topic, very important topic. The modern structure of benzene or molecular orbital treatment of benzene, and shows that benzene has a ring or we can say a cyclic with contain 3 alternate delocalized bonds to make the benzene is a highly stable. Then in next lecture we will start the resonance. So these are very important points. Thank you very much.